So whenever you guys see the terms directly and indirectly related to each other, when two things are directly related, it just means they move in the same direction. If we get an increase in one of them, the other one's going to increase as well. If something decreases, the other decreases accordingly. But when two things are inversely related, it means they move in opposite directions. So if we're increasing one thing, we're going to be decreasing the other. Now, one of the really important things here in the generation of these action potentials are going to be the different kinds of ion channels that we find within our cell membranes. The two major kinds of channels that are important here are called ligand-gated channels as well as voltage-gated channels. The leakage channels in the membrane are the ones that are always open. They're not necessarily the ones that are important for us here in terms of this action potential. That's going to be more of these gated channels here. The leakage channels just simply help to set exactly what that value is going to be inside the cell here at rest. Okay, so again, here are the types of gated channels. The two that we're going to look at here in this unit are called the chemically gated or the ligand-gated channels, and then the voltage-gated channels. A chemically gated channel is one that can only open in response to a certain chemical that binds to that receptor. This is usually something like a neurotransmitter or a hormone. But the voltage-gated channels, on the other hand, open in response to a change in charge across the membrane. Mechanically gated channels, they open in response to mechanical stimuli. Stretch, touch, and vibration are common examples here. Okay, so I included this figure here to kind of give you an idea of what the difference is between them. Here are the chemically gated channels on the left, voltage-gated channels here on the right. Notice with the chemically gated channel, it's closed on the left side of the diagram here. Notice at the top of the channel here, there's a little groove there called the receptor. When that receptor is unoccupied and there's nothing bound to it, the channel here is closed. What causes this channel to open is when a neurotransmitter or a hormone binds to that receptor, and now notice a channel opens up in the middle of it, and ions can now flow both in as well as out of the cell here. And in this case, as we start to rush positive charge into the cell, we know that initially the inside is negative, but as we start to move positive inside the cell, that's going to change to a positive value. And when the inside of the cell changes from negative to positive, that's